Solve the initial value problem. 1/2 times y double prime plus 2 times y prime minus y equals 0. And our initial conditions, we have y when x is 0 equals 3, and y prime when x is 0 equals -4. So this problem is going to be not as nice to solve. It's going to have a more complicated solution, and that happens sometimes, so we're going to do it. And yeah, so let's get started. So first thing I want to do is I want to multiply this entire equation by 2 to get rid of the 1/2. It's hard to work with fractions, so if I do that, I'll end up with just y double prime plus 4 y prime minus 2y equals 0. Then we use our guess we use every time of y equals e to the rx. And right, following the pattern that we've seen before, we're going to end up with 1 times r squared plus 4 times r minus 2 all times e to the rx equals 0 when we plug in, y into the difference equation here, I guess. Then next step, right, to figure out the value of r, we have to factor this thing. And unfortunately, that doesn't look very easy to factor in my head, so we're going to have to use the quadratic formula. So right, in this case, a equals 1, b equals 4, and c equals -2. Right, so quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. All right, well, let's see, -b, that's -4 plus or minus square root 4 squared, that's 16. Then we have minus 4 times a, which is 1, times c, so 4 times -2. And that's all over 2 times 1. All right, well, let's see, that's -4 plus or minus square root 16. That ends up being a plus 8. So 16 plus 8 is 24. All over 2. All right, well, that's -4. I can factor out this 24 is the same thing as 4 times 16, so that's the square root of 4 times the square root, of 6. And that's all over 2. So it ends up being -4 plus or minus, the square root of 4 is 2, so 2 squared is 6. At the bottom I have 2. Okay, at least there won't be a fraction in there, so I can cancel out the 2 here, so that ends up becoming a -2 and plus or minus square root of 6. So yeah, those are the two roots. So then we've got, y1 equals e to the -2 plus square root of 6, x, and y2 equals e to the -2 minus square root of 6, x. And the general solution, right, so ends up being, so I'll go ahead and write the general up here, so y of x, right, that's c1, y1 plus c2, y2. So that is c1 times e to the -2 plus square root of 6, x, plus c2 e to the -2 minus square root of 6, x. All right, well, now we get to solve for the initial conditions. So let's go ahead and do that. So we have y, let me just put a line there, y at x equals 0 equals 3. Let's go ahead and plug it in. So thankfully this comes out somewhat nice. So we end up with actually just c1 plus c2, because we end up with e to the 0 and e to the 0. So it's just c1 times 1 plus c1 times 2. C1 plus c2. And that has to equal +3 in order to satisfy the initial condition. All right, that wasn't so bad. Well, then we have to take the derivative. So that one isn't so nice. So y prime of x equals, well, you multiply the exponent down, take the derivative, so we get c1 times -2 plus square root of 6 e to the negative, I need my parentheses, e to the -2 plus square root of 6 x. I don't have room here, so I have to do plus c2 times, dropped on that one, it's -2 minus square root of 6 times e to the negative 2 minus square root of 6 x. Then we get to evaluate y prime, that's 0. Alright, well, let's see. So the e's, essentially, they turn into 1s because they end up as e to the 0. So it's c1 times negative 2 plus square root of 6 plus c2 times negative 2 minus square root of 6. And that all has to equal negative 4. So we'll end up with a system of equations now. Our system is, let's see here, yeah, c1 plus c2 equals 3. And didn't leave enough room for myself here. We got negative 2 plus square root of 6 c1 plus negative 2 minus square root of 6 c2 equals negative 4. And I have run out of room here, so I'm going to go ahead and continue on another sheet.